One morning, you wake up, draw back the curtain, and instead of the familiar sunrise, you see Earth, vibrant blue, suspended in the inky black of space. Breathtaking, like a radiant jewel gleaming in the infinite cosmos. Sounds like science fiction, yet this is the vision NASA is turning into reality. A village on the moon. Not flimsy tents, but homes 3D printed from lunar soil, solar-powered rovers gliding across rugged terrain, and even a miniature nuclear reactor to illuminate an entire outpost. The ambition doesn't stop there. This is the stepping stone to humanity's journey to Mars. Mind-blowing, isn't it? But what secrets lie behind this bold dream? Stay tuned, because the future of the cosmos begins now. On September 29, 2025, at the International Astronautical Congress in Sydney, acting NASA Director Sean Duffy unveiled this audacious plan.
We are going to have sustained human life on the moon. Not just an outpost, but a village. We're going back to the moon, and this time when we plant our flag, we stay.
NASA calls this vision Artemis Base Camp, the foundation for a permanent lunar village slated for completion by 2035. This is no temporary station like those of the Apollo era, but a self-sustaining community where humans can live, work, and conduct research for extended periods. The location? The moon's south pole, a peculiar region where the sun hovers near the horizon almost year-round, providing near-constant sunlight. Why here? Data from NASA's Lunar Reconnaissance Orbiter reveals that the permanently shadowed craters at the South Pole are rich with water ice, a treasure more valuable than gold. This ice isn't just for drinking. It can be split into oxygen for breathing and hydrogen for rocket fuel using in-situ resource utilization technology, ISRU. With just a small amount of ice, we could produce tons of oxygen and fuel, drastically reducing reliance on supplies from Earth. The village hinges on 3 core pillars designed by NASA for self-sufficiency. 3D printed habitats, homes of the future. Picture inflatable cabins shielded against cosmic radiation, housing 4 to 6 astronauts. Instead of hauling building materials from Earth, NASA will use 3D printers to construct walls from regolith, the moon's silicon-rich soil. Astronauts on the International Space Station have already tested this, mixing regolith with water from ice to create a lunar concrete, printing solid structures in microgravity. These habitats not only save tons of cargo, but will be buried at least 2 meters under regolith to block 90% of cosmic radiation, a lethal threat on the moon, which lacks Earth's protective magnetic field. Next-generation rovers, mobile companions. From the VIP rover, Volatile's investigating polar exploration rover, to the Lunar Terrain Vehicle, LTV, solar-powered electric vehicles capable of carrying 2 astronauts at 20 kilometers per hour across rugged terrain. By 2030, Artemis V will deliver the LTV, transforming it into a mobile home with sealed cabins where astronauts can live for up to a week, collecting rock samples and exploring hundreds of square kilometers. These rovers are more than vehicles. They're mobile laboratories, mapping resources critical to the village's survival. Nuclear power, the unyielding heart. Lunar nights last 14 Earth days, with temperatures plunging to minus 173 degrees Celsius, rendering solar panels useless. The solution? A compact fission nuclear reactor, generating 40 to 100 kilowatts, weighing under 10 tons, capable of powering 80 Earth homes or the entire lunar village. In August 2025, NASA issued a call to companies like BWXT to design this reactor, targeting deployment in the early 2030s. Launched from Earth, it will land gently and operate reliably in a vacuum, charging rovers and habitats without fear of power shortages. This is a historic leap. The United States will be the first nation to bring nuclear power to the moon, paving the way for long-duration missions. This is no longer a blueprint on paper. NASA has signed contracts for research, tested habitat concepts on the ISS, and issued a request for information for reactor builders. By 2035, the village will host astronauts for up to 180 days, transforming the moon from a fleeting destination into a true colony. It all begins with the Artemis program, NASA's most ambitious endeavor since Apollo. Artemis I in 2022 was a triumph. The uncrewed Orion spacecraft orbited the moon, testing the colossal Space Launch System (SLS) rocket. Now the journey with humans truly takes flight. First up is Artemis II, set to launch in April 2026. 4 courageous astronauts, Christina Koch, Victor Glover, Reed Wiseman from NASA, and Jeremy Hansen from the Canadian Space Agency, will orbit the moon for 10 days, venturing as far as 9,200 kilometers beyond it. This will mark the first human mission to leave Earth's orbit in over 50 years, since Apollo 17 in 1972. They'll test Orion's life support systems, gather data on human responses to deep space, and put the SLS rocket, a 98-meter-tall behemoth twice as powerful as the Saturn V, through its paces. If successful, this mission will prove we're ready to return. Next is Artemis III, a historic pinnacle, targeted for mid-2027. 2 astronauts will land near the moon's south pole, touching extraterrestrial water ice for the first time, staying for about 7 days to collect geological and environmental samples. Clad in advanced spacesuits, they'll navigate with rovers and test ISRU, converting ice into breathable oxygen on site. This mission isn't just the first step for a woman and a person of color on the moon. It's the data foundation for the lunar village. Then, Artemis IV in September 2028 will break ground on Gateway, a lunar orbital station, a space hub featuring the Esprit module from the European Space Agency, the Canadarm3 robotic arm from Canada, and contributions from Japan. Gateway will serve as a staging post for spacecraft, a rest stop for astronauts before landing, and a control center for rovers below. Artemis V in 2030 will bring technologies from India and Japan, delivering the lunar terrain vehicle to the surface and starting construction on the first habitats. NASA hasn't pinned down an exact date for the village's completion, but the goal is clear. By the 2030s, there will be a sustained human presence, with astronauts staying for months, not days. The SLS Block II rocket will haul 46 tons of cargo per mission, paired with SpaceX's Starship HLS for precision landings. This is the perfect fusion of NASA's expertise and commercial innovation, a new model for space exploration. But NASA isn't alone in this race. The Artemis program is part of a 21st-century space race, with the moon's south pole emerging as the new battleground. Why? Because the permanently shadowed craters there hold vast reserves of water ice, estimated at billions of tons, enough to produce oxygen, hydrogen, and even fuel for Mars missions. Whoever controls this ice will hold the key to humanity's path into the cosmos. China and Russia have announced the International Lunar Research Station, ILRS, a global lunar research station targeting completion by 2035, also focused on the South Pole. Japan and India are collaborating on the Lunar Polar Exploration (LUPEX) mission, probing water ice concurrently with Artemis. Meanwhile, the European Space Agency and Australia have joined forces with the US through the Artemis Accords, now signed by 56 nations, rooted in the 1967 Outer Space Treaty to ensure peaceful exploration. Yet every dream comes with a cost, and Artemis is fraught with challenges. First, the financial hurdle. NASA's budget faces a potential 24% cut in fiscal year 2026, dropping from $24.8 billion to roughly $18.8 billion, enough to stall the entire program. According to the Planetary Society, this threatens critical missions. The technical obstacles are even more daunting. During Artemis I in 2022, the Orion spacecraft's heat shield suffered cracks and ablation of its avcoat layer during re-entry, forcing NASA to redesign the trajectory and materials to ensure safety. SpaceX's Human Landing System, HLS, has yet to be tested with crew, and complex supply chains could push Artemis III from 2025 to 2027. NASA's Inspector General has warned that technical errors may cause further delays. The nuclear reactor is a ticking time bomb. It must launch safely from Earth, land without braking, operate in a vacuum at -173 degrees Celsius, and prevent radiation leaks. A single misstep could turn the lunar village into a disaster. Habitats must be buried 2 meters under regolith to shield against cosmic radiation. But digging on the moon, with sticky dust and 1/6 gravity, is a technical nightmare.
Still, NASA remains resolute. These challenges are lessons for Mars, where nights are longer and the distance far greater. So why is NASA taking such risks? Because the lunar village is just the beginning. It's the springboard for the Moon to Mars strategy, paving the way for human exploration of the Red Planet. Every technology tested on the Moon, from in situ resource utilization (ISRU) and nuclear reactors to 3D printed habitats, will be applied to Mars missions. Imagine by 2040, 20 people living on the Moon, studying rocks, ice, and helium-3. These discoveries could transform our understanding of the solar system and unlock a space economy worth trillions of dollars. This is no longer science fiction. This is the race of the 21st century. Will the United States lead the charge, or will China surge ahead? Will the dream of a lunar village become reality or fade as a vision just out of reach? The future of the cosmos is unfolding now, and you are living in this historic moment. If you want to join us in following this epic journey, don't forget to like, subscribe, and share, because the quest to touch the stars needs you along for the ride.